Hey everybody, happy Wednesday. Okay, so today, hopefully you turned in the pixel art assignment yesterday. You got to finish that up and submit that, and I'll be putting that grade in the gradebook soon. Today we're going to move on. So we are actually in the last piece of Unit 6. We've made it to the end of Unit 6. Remember, we did Unit 6 in two parts. We did our exponents first, then we did our multiplying polynomials, and then we're going to talk about something called factoring today. Okay, so let's go over to Canvas here and look at what we've got. You have your check-in, and then at the bottom of the page, you're going to have like an assignment and then an exit ticket. So I'm going to go over part of the assignment with you, and then the exit ticket I need you to do on your own, and I'll take a grade on the exit ticket. So what I'm filling out in this video mainly is going to be your notes. So remember, if you haven't already, you're pretty far behind, but you need to come back up to the top and make a copy of this journal notes here. Or if you're working in a notebook, that's completely fine. If you're like writing what I'm putting on the screen, just writing it in a journal, like a spiral notebook or something, that's completely cool too. That's fine, but that's your pieces on Canvas today. I'm going to come back to this factoring step 1 practice in just a minute. For now, let me open up my iPad here. Okay, so this is where we stopped, Unit 6, Lesson 6. So if you haven't been filling out your table of contents, make sure you're doing that too. So now we're going to go to Unit 6, Lesson 7, Factoring Trinomials. So right up above here, we were multiplying, okay? So I want you to think, let me go up to like here, right here. These problems like 1 and 2. Remember I told you that was going to be our real focus? Let my computer screen catch up. Oh my goodness. Okay, so I told you problems 1 and 2 were going to be our real focus. So notice what we were doing is we were given problems. Let me get my little pen out here. We were given problems that looked like this, 2 binomials that were being multiplied, and then we ended up with something that looked like this. And I said, notice that our answer has 3 terms in it. It's a trinomial. Well, factoring just means you're going backwards. That's all it is. We've been given something that looks like this, ax squared plus bx plus c, so 3 terms. And we actually want to come back and find the 2 binomials that we would have started with. So factoring, you can almost think of it, it's almost like dividing, but it's really more like undistributing. So there's 2 ways to undistribute. One way is just to factor out the GCF. So when you say GCF, that stands for greatest common factor. So if I was to give you something like 30 and 25, and I said, what's the GCF of those 2 numbers, 30 and 25? Well, I would say, okay, I know I could say 30 is 3 times 10. And then I could also say 30 is, 5 times 6. Well, 25 is pretty much 5 times 5. And then 25 times 1. I could do the same thing over here. 30 is 1 times 30. And then I'd be like, oh, okay, well, I mean, that's pretty much it. And I noticed the greatest common factor between the 2 of them is the 5. That's the biggest number that's common between the 2 of them, okay? So when you're asked to factor out like the GCF, they really want you to factor out, undistribute the greatest common thing. It can be a number, it could also be a variable. So I want you to think, it's as if we had something sitting out front here times something inside the parentheses. So whenever you're factoring out a GCF, let me rewrite that. You actually are undistributing. So I'm going to look and I'm going to say, okay, between 6x, 9x, and 33, what number could I divide 6, 9, and 33 by? And what's the biggest number? Well, 33, I'm like, that's just 3 times 11, right, guys? And I don't think I can divide 6 and 9 by 11, so it's got to be the 3. So then you can come over like on the side or somewhere and you could say, well, what's left inside my parentheses? So you have to think, if I was going to multiply 3 times the inside, well, what did I have to multiply the 3 by to get the 6 up here? What I had to multiply by 2, and then there's also an x squared. So 3 times 2x squared would have given me the 6x squared. And then what did I have to multiply the 3 by to get the 9x? Well, you actually, guys, you could divide each piece. Well, what's 9x divided by 3? Oh, well, 9 divided by 3 is 3. So I'd be left with a 3 and an x. And then we already know the 33 would have to be 11. And the good thing about factoring out GCF is you can always multiply back through to check it. So you could redistribute the 3 times each piece. And if we did that, we would get our original trinomial up here. Let me do one more with you, okay? So let's look at B. Okay, so I'm trying to factor out, I'm trying to find some number that I distributed towards all these pieces. And I'm like, is it a number, or maybe there's also a variable too? I don't know. Well, I'm seeing negative 2x squared minus 8x and a 48. Well, look, the first number is a 2. So what's the only thing that's common? 2 is only 2 times 1. And I don't want to ever factor out a 1 if there's something greater. I could do the 2, right? Isn't 8 divisible by 2 and 48 divisible by 2? Yeah. And because this 2 is negative, we're going to go ahead and pull out a negative 2. So anytime your first term is negative, you're going to actually be factoring out, undistributing that negative. Okay, well, all that would be left here is x squared, because negative 2 times x squared is negative 2x squared. But then I'm thinking about it, I ended up with a negative 8 here. So again, you could come over and say negative 8x divided by negative 2. Oh, well, negative 8 divided by, that becomes a positive. Negative divided by negative is a positive. And 8 divided by 2 is 4. So I would be left with 4x. And you could think, multiply that back. Yep, negative 2 times 4 is negative 8x. And then the 48, well, again, I could come over to the side and say, well, what's 48 divided by the negative 2? And we could put that in your calculator if you wanted to, and you should get negative 24. So your GCF is actually the negative 2 out front. Now, sometimes I'm going to do C with you as well. I'm looking and I say, okay, I have 5x squared and 20x. Remember, I'm looking for that number or that term that I could actually undistribute. It's actually a term. Okay, well, I can see I could divide 5 by 5 and 20 by 5. Boom, it must be 5. Yes, it is 5. But what else is common between 5x squared and 20x? What else do you see sitting there? Yes, there's an x. Now, I want you to think. Students will say, oh, x squared. But now look over here. There's only one x with this term, but this one has 2, x times x. So I can only factor out 1. I can't factor out 2 because the 20x term only has 1x. So the greatest number I can factor out is 1. Okay? So 5x. So then I have to multiply back. Well, 5x times what would give me 5x squared? Well, I would have to multiply it by an x. And again, you could think of it like dividing. 5x squared divided by 5x. Oh, well, the 5's will cancel. And then you could think of this x squared. Remember our powers here? If I had 2, 1 would cancel, and I'd be left with just 1x. And then you could do the same thing with the 20x. You have to think of it like dividing, and eventually you'll be like, oh, yeah, the x's would cancel. And then 20 divided by 5, whoa, that equals 4. So I would just need a 4 here. Okay, so I want you to do D on your own. So this is something called factoring out the GCF. Finding that greatest factor, common factor that we could undistribute. So try D. So this box here, the next box that comes up with this big X, we're like, what is going on here? This is an important thing that we need. I'm not going to do this box with you right now. We may come back to this later, but I'm actually going to skip on over. We are going to use something like this X, because this is part of factoring. So now, remember what we did in our multiplying polynomials notes. Remember, first thing we did, we distributed one term. But then we had things where we were like, wait, we might have something like this. X plus 3 times 2x minus 4. And that's when I said, hey, remember, like, this is so much to distribute. I have 2 terms now out front instead of 1. So we're still undistributing. But remember, when we multiplied something that looked like this over here on the side, we ended up with an answer that looked like this within 3 terms. So I'm still needing to undistribute. Now, you think of factoring as undistributing. But remember how this got a little complicated, and so we used the box to help us distribute everything? Aha, that's why the box is showing up. So before, what we were doing was we were having pieces on the outside of our box. We multiplied them to get the inside of the box to get an answer that looked like this. Well, now we're doing the opposite. We actually have been given the inside of the box, and we're trying to find the outside pieces. We're going backwards from what we just learned to do. Okay, so in order to do this, there's several steps. So we're going to break this down step by step. And that's why your assignment today is factoring step 1 practice. We're going to practice step 1. So the first thing we have to do is, because remember, when we had something that looked like this, and it came out of the pieces in our box here, remember how we ended up combining these two to get this middle piece here? Well, we have to be clever. So now we have to break that middle piece back apart to fill in the inside of our box so we can find the outside of the box. So that's what this X helps us do. Now I'm going to erase this because we're going to actually come back to this problem. That's what this X over here on the side does. So the first thing you need to do is find A, B, and C. Identify them. Now, if you look right up here, it tells you where A, B, and C are. These are numbers we are going to use over and over and over and over again. Now, what I do want you to notice is that on A, B, and C, the X squared and the X sit beside them. X squared and X are not part of A, B, and C. So for instance, on this very first example right here, A is just the number 4. B is just the number 11. The X doesn't go with it. We're just actually interested in the coefficients. We're interested in the numbers in front and then the little tiny number on the end, the 6. So we're just interested in the numbers, the coefficients and the constant at the end. I don't care about the X squared and the X for this part. So A, B, and C are real important numbers. So what we need to do, and this is going to seem, it seems weird, like, Ms. Robinson, what are you doing? But I promise you in 2 or 3 days, we're going to put all this together and it'll make sense why I'm breaking it down into steps for you. Because we need to practice each step and get good at each step before we put all 3 steps together. It's 3 steps. So step 1 today. Okay, so the first thing you're going to do is you need to identify A, B, and C. Check, we did that. Then what you're going to do is you're going to multiply A times C, and you're going to put that number when you multiply them in the top of your X, and then you're going to put B in the bottom. Well, B is 11. I already know that, right? Let me grab the color. So B goes down here. That's 11. And then I need to do A times C. Okay, A times C is 24 because 6 times 4 is 24. So there's my A times my C. Okay, so now what I need to do is, oh my gosh, okay, I'm back. I don't know if you guys noticed, but my computer just completely cut off. Okay, we filled out the top and the bottom of our X, so 24 and 11. So those are the 2 numbers we're going to be working with. So here's what we need to do. We need to find the factors of 24. So remember, a factor is just some number you multiply to get another number. So here's what I like to do. I like to come over here and I like to make me a little chart, okay? So I need to find 2 numbers that multiply to be 24, but when I add those same 2 numbers up, I want it to equal 11. Okay, now hang with me. I like doing this. It's actually kind of like a riddle. So we're going to camp out here doing these problems like this for a little while. Okay, so I need to find 2 numbers that when I multiply them, I get 24, but when I add them, I get 11. So here we go. So 24, I could do 1 times 24. Isn't that? See, I'm multiplying to get 24, okay? So let me put the dot there so you know we're multiplying on this side. 1 times 24 is 24, but 1 plus 24 equals 25. So that's not going to work. That doesn't work for me. Okay, so let's try it again. What's the next thing? Well, and I did 1, so then I could say, well, 2. 2 times 12 is 24. Okay, 2 plus 12 equals what? 14. That's not going to work. So those 2 numbers don't work either. So I'm looking for 2 magic numbers. I multiply them, I get 24. And when I add them up, I'm looking to get 11. Okay, so then I go on 3. Is 24 divisible by 3? Can I do 3 times some number? I always like to start at 1 and I work my way up from there. 3 times what? 3 times 8 is 24. Yes, those work. So let's add them. 3 plus 8 equals, 3 plus 8 equals 11. Ding, ding, ding. Hey, we have found our magic combo. 3 plus 8 equals 11. So my magic numbers are 3 and 8. They go on either side of your X, and I like to box those babies in because they are a magic combo, and I'm going to use them when we go to fill in the box over here. 3 and 8 are actually the magic combo that are going to help us break apart this middle term, 11x. Because remember, we had 2 pieces in this square and this square that we added up to get that middle piece. Okay, so this is real important. This a times c in the top and b in the bottom, and finding the 2 numbers that multiply to be one thing number, but then when we add those same numbers, we get this bottom number, this b in the bottom. We're going to camp out here. Okay, so that's what we're stopping. We're not moving further until we get it. We really know we're good at this. So on Canvas, let me bring the other assignment up for you. It is right here. Step 1, factoring, practice. That's what we're doing here. I want you to practice this today. I'm giving you a lot of different problems. I'm going to go through and show you how to work some of them. Okay, so number 1, they gave me my trinomial, 4x squared plus 11x plus 6. And they've already given me A, B, and C. And notice I'm telling you, you want 2 numbers that multiply to whatever A times C equals. And when you add them up, you get B. So here's what I want you to do on all of these. I want you to draw your X. And remember, I want you to label it A times C in the top, B in the bottom. Okay, here we go. Well, B is 11. And A times C is 24. We just worked this problem. Did you know? Remember this? This was 8 and 3. Okay, so I just worked this one to show you like that. So notice 1, 2, 3, and 4, they've gone ahead and labeled A, B, and C for you. Aha, but when you get down to number 5, it's different. They've given you the trinomial, but now I need you to tell me what are A, B, and C, because students tend to get confused and they throw in some X's with an A, B, and C. A, B, and C are just numbers. So A is the 8, because that's what's in front of X squared. B is, be careful, negative 12. Let me zoom in here. C is 4, the number on the end. So make sure you're able to identify A, B, and C, and their sign. Be careful, the sign has to go with them. Notice there's no X's in A, B, and C. A, B, and C are just the numbers in front. Okay, so then we do our X. A times C goes in the top, B goes in the bottom. Okay, well, B is negative 12, and then A times C is 8 times 4, which is 32. Okay, so then I'm gonna make my little chart. I'm looking for 2 numbers that when I multiply them, I get 32. But then when I add them up, and I get a negative 12. I'm gonna take up more space here. I'm gonna start with my chart. Okay, now I'm noticing when I'm adding, I'm getting a negative number. So think about it. If you're gonna add and get a negative, one of your numbers that you're adding has to be negative. So I want to somewhere on your paper, you write this. I'm going to write it over here on this problem. Don't put it there. Put it somewhere else on your paper. Oh, let me say also this assignment. I noticed, I know I just gave you this sheet. If you have a printer, print it out. If you don't, just write these problems on notebook paper and work them from there. It was just impossible for me to put this in Canvas we don't have Cami anymore where I can give it where you can write on it. So it's been a struggle, but that's why I'm just giving you things and telling you write them on paper. Okay, and then you can just upload a picture of your paper to submit the assignment. So remember, a positive times a positive will give you a positive. If you multiply a negative times a negative, you get a positive. Okay. If you multiply a negative times a positive, you're always going to get a negative. So we need to get positive 32. So we actually need to be multiplying a negative number and another negative number. That's the only combination that's going to work for us. If we are going to add them, it's like eyeballs. If we add them up and get a positive, But then if we add them up and get a negative, we're going to add these two numbers, get a negative, but when we multiply, we got to get a positive. We have to be working with two negative numbers here. So when we throw in negatives, it gets a little tricky. Got a bell right here. Okay, so let's try this. So I know I'm looking for two negative numbers. Well, I'm always going to start with 1. So I have -1 times what? -32. But then -1 plus -32 is -33. And use your calculator to add this if you need to. It's no problem with that. So that one's not going to work. I'm trying to add to get -12. Okay, so then I go to 2. -2 times what? -16. Okay, well, -2 plus -16 is -18. That's not going to work either. I'm looking for -12. Let's do -3. Well, is 32 divisible by 3? So if you're not sure if a number is divisible or if you can do 3, type it in your calculator. So if you type 32 divided by 3 in your calculator, you get the decimal 10.66666. Okay, if you get a decimal, it's not divisible. You have to skip that number. So it's not evenly divisible by 3. So then we're going to go to -4. So we know we're looking for two negatives, remember? Okay, so -4 times what? -8. Let's add it up. -4 plus -8. -4 plus -8 equals -12. There's my numbers right there. That's the two I needed. -4 and -8. That's my magic combo. That's the two that I needed right there. Okay, so this is an example where you're adding to get a negative, but when you multiply, you get a positive. Well, if you're adding to get a negative, one of those numbers has to be a negative. And if you're multiplying numbers to get a positive, they both have to be positive. So you have to go back and think about those rules. Let's look at number 9 because it's a little different. I'm going to try to work one of each style for you. Okay, so in number 9, I'm going to identify A, B, and C first. So remember, A is the -2. It's just the number in front of x squared. B is 3, and C is 14. So B is always the number in front of x. These pieces may be rearranged, but A is always whatever's in front of x squared. B is always in front of what's in front of x. Okay, so here I go with my x. So remember, A times C goes in the top, and B goes in the bottom. Okay, here we go. Well, B is 3. And then A times C is -2 times 14. Well, -2 times 14 gives me -28. Okay, so let me make my table. I'm trying to multiply to get -28. So when I multiply it, I want to get 28. And then when I add, I want to get 3. Okay, so let's think about it again. We know if we do a positive times a positive number, we get a positive number. We know if we do a negative times a negative, we get a positive number. But if one's negative and one's positive, we get a negative answer when we multiply. And that's what we have here. We're trying to multiply to get -28. So we know one of our numbers this time has to be negative, not both of them, just one. Okay, so let's start. I always start with 1. Now, if you know one of your numbers has to be negative, make one of them negative. I'm going to show you what happens. So -1 times 28. That's -28. Well, -1 plus 28. No, that equals 27. That's not going to work. Let's go to 2. -2. I'm just making the first number negative. You'll see in a minute when it doesn't work what we need to do. Okay, so -2 times 14. Well, -2 plus 14 is 12 when I add them up, so that's not going to work either. Okay, so now let's try, what about -3? Is 28 divisible by 3? So remember, if you're not sure, type it in your calculator, 28 divided by 3, or 28 divided by -3. You're going to get a decimal. So no, it's not divisible by 3. So we have to go to 4. So I'm going to skip 3, and now I go to 4. So -4 times what? And if you're not good at your times, then divide and say -28 divided by -4, it'll tell you the number. Well, it should be 7. Okay, so -4 plus 7 equals, 3. Boom. That's my magic combo. It worked. And we have the signs right. The 4 does need to be negative, and the 7 needs to be positive. Now, let's say you were working this problem. I'm gonna come down below here. Let's say you're working this problem and you actually had said 4 and you were making your second number negative, because you could have. I told you just pick one and make it negative. Well, when you added them, you would have gotten 4 plus -7, which would have given you -3. So if you ever get the number that you're looking for, but the sign is off, that's when you know, go swap it. Make the 4 negative and not the 7. That's your clue to look for. If you find the number, but you're just off by the sign, you have the right combo. It's 4 and 7, but your negative is on the wrong one. And this only happens when you're doing one negative number and one that's positive. That's usually the only time that this happens, okay? So work on some, I like doing this because it's more like a riddle to me. I don't feel like we're doing so much like algebra and stuff, but this is the first step in learning to factor, undistribute a trinomial so that we get starting back with those 2 binomials that we started with that were multiplied in the first place. So I know this video is kind of long, but I really wanted to show you all the different examples. So go through and work the rest of them on this sheet, and then the exit ticket is similar to this. This is what I want you to do. I want you to find A, B, and C. I want you to label your X, and I want you to find the 2 magic combo numbers that go on either